Okay, so this question asks evaluate 0 from 0 to 1, 2x minus 1, e to the 2x dx. So let's write it. 0 to 1, 2x minus 1, e to the 2x dx. And since we see 2x minus 1 and e to the 2x, we are going to use the integration by parts. So Liet, L logarithmic, inverse trig, algebraic, trig, and exponential. And you choose u in the left order. So since we see a algebraic and exponential, our u will be 2x minus 1, and du will be 2 dx, db would be e 2x dx, and b would be e 2x over 2. So integration by parts is ub minus b do. So u is 2x minus 1, b is e 2x over 2 minus e 2x over 2 times 2 dx. 2 cancels out, 2x minus 1, e 2x over 2 minus e 2x dx. So 2x minus 1, e 2x over 2 minus e 2x over 2, integrating from 0 to 2. Let's plug it in. So 1, then it's 1 e 2 over 2 minus e 2 over 2 minus negative e 0 over 2 minus e 0 over 2. So this thing will be cancelled out. So minus 1 over 2 minus 1 over 2. So it's going to be just 1. So the answer for this question is C. Okay, so this question asks which of the following statements are true. Let's just look at the first one. U equals tangent x is the most appropriate substitution. Since tangent is odd, it'll make sense for this question. If you look at the past exam archive solution, one is both true and false. So if you want to think this one is true, go for it, but it can be false according to the exam solution. But either way, it doesn't really matter, because I'm going to show you how to solve it. U equals tangent x is the most appropriate substitution. But if you don't think it's true, that's fine, because the answer is both C and D. So okay, so u equals tangent x is the most appropriate substitution. Let's try it. So then it's going to be u to the fifth, and then we see, let's start it from the beginning. Tangent to the fifth power, secant to the fourth power x dx. So u equals tangent x, du would be secant squared x dx. So we see tangent to the fifth power, this is going to be u to the fifth power, and secant squared x can be, secant to the 4x can be divided into secant squared x and secant squared x. And we are going to change secant squared x as tangent squared x plus 1, since secant squared x is equal to 1 plus tangent squared x, with trig identities, and secant squared x dx. So u to the fifth power times, this is going to be u squared plus 1, and then it's du. So this eventually becomes u to the seventh power plus u to the fifth power du. This is just going to be u to the eighth power over 8 plus u to the sixth power over 6. So there you go. You have that. Oh wait, yeah, that's right. So we have that. So after that, you just have to change into tangent to the x to the 8th power over 8 plus tangent to the 6th power over 6. So you can solve it. So this can be, I think it's right personally, but I think they kind of made, when the professor was making the exam, he or she made a mistake. So I'm gonna consider it as right. So 2, u equals sine 2x is the most appropriate substitution. How do you know it is most appropriate substitution? Since cosine to the cube power, cosine is odd, then that means u has to be sine 2x. So if you look at it, if you don't think it's right, all you have to do is just solve it. So u equals sine 2x, okay. Then du would be 2 cosine 2x dx. So this thing, cosine cube 2x sine 4 2x dx can be changed as here due to the 4x dx, and then cosine cube as changed into cosine x and cosine squared 2x. Oh, cosine 2x. There we go. And then we know cosine 2x is like this. So cosine 2x dx can be written as du over 2. So 2 over du, cosine 2x, u to the 4th power, and then cosine squared 2x can be written as 1 minus sine squared 2x by trig identity. So 1 minus u squared du. Wait, du is already written there. There we go. You just have to solve it and integrate it. So it is the most appropriate substitution in this case because cosine is odd. And if you know that if cosine is odd, that means you can find the derivative easily by putting u equals sine 2x. And it's like the thing that you have to memorize. If cosine is odd, u has to be sine. So 2 is right. Let's look at 3. 3. 0 to pi over 2 cosine squared d theta. So the cosine squared theta, this is the what's it called? Half angle theorem, I think. So this is just same as 1 plus cosine 2 theta, 0 to pi over 2. If you integrate it, 1 over 2 will come out. Wait, if you have to actually integrate it before. You have to change it. Sorry. 0 to pi over 2 and d theta, and then this will be just 1 over 2 theta plus sine 2 theta over 2, and integrating from 0 to pi over 2. So 1 over 2 pi over 2 plus sine pi over 4, and then minus 0, 0. So 0 is cancelled out. Pi over 4 because plus 0 because sine pi over 4 is anyway 0. So pi over 4 is right. So the number 3 is right. So all of them are true. So it's C. But in the answer choice, it is both C and D. So whatever you prefer for the number 1, if you think u equals tangent x is the most appropriate, there you go. If you don't think so, then it's also right. So it's both C and D for this question. Okay, so number 3, we want to find the work required to, we want to find how tall is the tank and work is given. Okay, so the work is the same as integrating P as, what's it called? P as density and G as gravity and volume. And that's equal to 9 joule. Okay, and we are given P is 1/3, G is 10. Cool. So it's 1/3 times 10 times V is equal to 9 joules. And it's integrating from, it's required to pump all of the oil from the top and out of the tank, meaning it's going to be starting from 0 to H height. So we're given that. The volume is, it's rectangular, so 3 times 2 times H, which is 6H. So it's from 0 to H, 1 over 3 times 10 times 6H equals 9 joule. So this becomes 20H, right? 0 to H equals to 90 joule. 10H squared integrated from 0 to H is equal to 90 joule. So 10H squared is equal to 90. H squared is 9, so H is 3. So the answer for this question is B. Okay, so this question asks what does the integral 1 over 4 plus x squared 3 over 2 dx become after making the trigonometric substitution x equals to tangent theta. Okay, so it's given x is equal to 2 tangent theta. And let's find dx. Dx is equal to 2 secant squared theta d theta. So let's write it. 1 over 4 plus x squared 3 over 2 dx. So dx is given as 2 secant theta squared, 2 secant squared theta. Let's write it over 4 plus x squared. So 4 plus x squared becomes 4 tangent squared theta. So 4 plus 4 tangent squared theta, 3 over 2. This becomes 2 secant squared theta d theta, 4 1 plus tangent squared theta, 3 over 2, 4, 3 over 2. So 3 over 2 becomes 8. And this is just 2 secant squared theta, d theta on top. And 1 plus tangent squared theta. 1 plus tangent squared theta is same as secant squared theta, if you remember your trig identity. So this will be just 8 secant squared theta, 3 over 2. So this just becomes 1 over 4 secant squared theta d theta over secant cube theta, which is same as 1 over secant theta d theta, which is same as 1 over cosine theta d theta, right? Integral. So the answer for this question is C. Okay, so this question asks, if a trigonometric substitution is used to solve square root of 24 plus 10x minus x squared dx, the hypotenuse of the associated right angle triangle is question mark. Okay, so we have that integral of 24 plus 10x minus x squared dx. Okay, so you can change this square root as like completing the square. So we're gonna write this as negative x squared plus 10x plus 24 dx for our sake. And then we're gonna group it by negative for x squared and 10x. So negative x squared minus 10x plus 24 dx. We have that, and then so completing the square is dividing by 2 for the coefficient of x, which is in our case it's x squared minus 10x. So if you divide it by 2, it's negative 5, right? So it's gonna be negative x minus 5 squared. Okay, so negative x minus 5 squared, this becomes negative x squared plus 10x plus 25, right? Oh, 25 minus 25, right? So if you write it negative 25, in our original equation, we don't have negative 25. So what you need to do is plus 25 in order to cancel out, right? So what we're going to do is plus 25, and then we have 24 in the very beginning. So this just becomes negative x minus 5 squared plus 49. So if you draw the triangle, this side will be 7, and then x minus 5. So this side will be 49 minus x minus 5 squared. This is exactly equal to each other, right? So in this case, our hypotenuse is 7. So if you remember your Pythagorean theorem, you can do this. Or if you remember your a squared minus x squared form, and then if you remember a squared is our 49 and a is 7, you can use that too. So either way, whatever you prefer, go for it. But the answer for this question is E. Okay, so this question asks to evaluate from 0 to 1 x minus 4 over x squared minus 5x plus 6 dx. So in this question, you have to use decomposition technique. So let's write it, x minus 4 over x squared minus 5x plus 6 dx from 0 to 1. And you can decompose x squared minus 5x plus 6 as x minus 3 and x minus 2, right? 0 to 1 over x minus 4 dx. And you can write x minus 4 over x minus 3, x minus 2 as if you decompose x minus 3, a over x minus 3 plus b over x minus 2. You want to get rid of the denominators, so you multiply x minus 3, x minus 2 in both sides, then this just becomes x minus 4 equals a x minus 2 plus b x minus 3. So we have that, and then what we're going to do, we're going to plug in the values in x to find the value for a and b. So what we're going to do is plug it in x equals 2, this becomes negative 2 equals negative b, so b is equal to 2, x equals 3, this becomes negative 1 equals a, and b cancels out, so a equals negative 1. So we find a value and b value. Okay, that's good. So let's put it back to our original equation. This becomes negative 1 over x minus 3 plus 2 over x minus 2 dx, integral from 0 to 1. If you remember your logarithmic function, ln x derivative is same as 1 over x, right? Which is same thing as this thing. So this negative 1 over x minus 3 becomes negative ln absolute value x minus 3 plus 2 ln x minus 2, and then it's integrated from 0 to 1. Now let's plug it in. Negative ln negative 2 plus 2 ln negative 1 plus, because it's negative sign, so negative negative becomes plus ln negative 3 minus 2 ln negative 2. Though you might wonder why this becomes plus and negative, because if you do this, negative ln x minus 3 plus 2 ln x minus 2 integrated from 0 to 1, negative ln negative 2 plus 2 ln negative 1 minus ln 0 minus 3 plus 2 ln 0 minus 2. That's why this negative negative becomes positive and negative positive becomes negative. So, which is why it's just simple algebra stuff. So, anyways, so this thing eventually becomes negative ln 2 plus 2 ln 1, because it's absolute value, and then plus ln 3, and then minus 2 ln 2. Okay, ln 1 is 0, so it cancels out, and we have ln 3 minus ln 2, and then negative 2 ln 2, which 2 can go up as a power, so it can be negative ln 4. So this just becomes ln 3 over 8, which is E. Okay, this question asks which of the following is the correct form of the partial fraction decomposition. Okay, so we see the denominator. We have x squared, x plus 1 squared, x squared plus 1 squared. So since we have x squared, this can be decomposed as x, and we are going to decompose at the x, right? So in this case, x squared, if it's repeating, this becomes first one is x, then it's going to be the second one is going to be the x squared. And since it's x and the coefficient is 1, the power is 1, sorry. So the numerator for x will be just constant a, and x squared is repeating value, so it's not going to be bx, it's going to be b instead. And also plus x plus 1, so x plus 1 squared can be divided into x plus 1 and x plus 1, right? So it's going to be x plus 1 for numbers for the third term. And then since x plus 1 is a power of 1, so the numerator will be power of the denominator minus 1, so 0 power, meaning it's going to be just constant c. And then d will be repeating value, x plus 1 squared. Since it's repeating value, it's still following the x plus 1 power. So this is power 1 minus 1 is 0, so the constant d comes. And then we see x squared plus 1 squared. So x squared plus 1 squared can be divided into x squared plus 1. And since it's power of 2, so the denominator will be ex plus f, because it's power of 2, and the denominator will be power of denominator minus 1. So it's first power, so ex, and then we need to have a constant. Since it's repeating, it's going to be x squared plus 1 squared, and it will still follow the same power of the denominator, so the numerator will be gx plus h. So the answer for this question is E. Okay, so this question asks to evaluate from 0 to infinity x e to the negative x squared dx. Okay, let's do that. 0 to infinity x e to the negative x squared dx. So in this question, we can just easily do u sub. So u equals negative x squared. du becomes negative 2x dx. So x dx is same as du over negative 2. Okay, and then since u equals negative x squared, this domain becomes 0 and negative infinity, and this is gonna be negative 2 over du for x dx, and the e to the u power, because e to u power, as u equals negative x squared. So we have that. We can take out the negative 1/2 in front of it, negative 1/2, 0 to negative infinity, e to u du. So negative 1/2 e to negative infinity minus e to 0. So this just becomes 0, and this will be just positive 1/2 e to 0, which is 1 over 2. So the answer for this question is B. Okay, so this question asks to find the exact area of the surface obtained by rotating the curve. Okay, so the surface area equation is, if you remember, 2 pi integral fx square root of 1 plus f prime x squared dx. So our fx is given as 2x, and f prime x will be just 2, and f prime x squared is equal to 4. So we have everything. So surface area is equal to 2 pi, integrating from 1 to 3, 2x square root of 1 plus f prime x squared is 4, so 1 plus 4 dx. So this becomes 2 pi, 1 to 3, 2x square root of 5 dx. Square root of 5 can come out, 2 pi square root of 5, 1 to 3, 2x dx. 2 pi square root of 5, x squared, integrating from 1 to 3, 2 pi square root of 5, 9 minus 1. So this just becomes 2 pi times 8, 2 pi square root of 5 times 8, 16 pi square root of 5. So the answer for this question is A. Okay, this question asks to find the centroid of a thin plate. So if you remember the coordinate of the centroid, so x is 1 over a x times fx minus gx dx. So and then the y coordinate would be 1 over a, 1 over 2 fx squared minus gx squared dx. So let's first find the area first. 1 over a area. Let's draw it first actually. So y equals ln x. So like this. Y equals 0. X equals 1. X equals e. And the area is this area. So the area is same as the bigger height minus small height, which bigger height is y equals ln x and smaller height is y equals 0. So this area will be just ln x dx, and it's from 1 to e, and we are given that value is 1. So simple. So in our case, we just have to do x equals x times fx minus gx dx, and then y will be just 1 over 2 fx squared minus gx squared dx. There we go, gx squared dx. Yeah. So in our case, fx is the bigger height, bigger function, like the one that's above the gx. So fx is fx is located higher than y equals 0, so fx is y ln x. Gx becomes 0. So our x coordinate will be x times ln x dx, and it's integrated from 1 to e, which is exactly the same as 1 plus e squared over 4. So that's one option. So it's gonna be either A or C or E, not B or D. Cool. Got rid of that. Y is 1 over 2. So it's from 1 to e. Our fx is the one that's on top of it, which is ln x. So ln x squared. And gx is 0. So gx 0 is 0. So it cancels out. So it's going to be ln x squared dx. So this is 1 over 2 and e minus 2. So e minus 2 over 2, which is A. Okay, so which of the following statements are true? So let's look at the first one. So it's the sequence 1 over square root of n, So if it's sequence, it's limit n to the infinity, 1 over square root of m. This is same as 1 over infinity, so it equals to 0. So it converges, yes, right? Second one, it's the series. It's different than sequence. So series, n equals 1 to infinity, 1 over square root of m. So if you remember, So this can be written as n equals 1 to infinity, n to the negative 1/2 power. So if you remember your previous series test, if the p value is, the absolute value of p is greater than 1, then it's converging. So since our case is 1 over 2, which is less than 1, so it diverges. So 2 is not right. Number 3, sequence. Okay, sequence, limit n to the infinity, sine 2n minus 1 pi over 2. Let's plug it in. So if it's n equals 1, it's sine pi over 2. N equals 2, then it's sine 3 pi over 2. N equals 3, it's sine 5 pi over 2, right? So if you draw it, sine pi over 2 is 1, right? So 1 value. Sine 3 pi over 2 is also 1. Sorry. And sine 5 pi over 2 is also 1. So it's like zigzag, zigzag. So it is bounded from 0 to 1. So 3 is right. So the answer for this question is D. Okay, so this question asks, does the series n equals 1 to infinity 1 plus 3n over 7n converge? Okay, and if so, what is the sum? Let's look at it. So in this case, we can rewrite this as n equals 1 to infinity 1 over 7n plus 3n, n looks weird, 3n over 7n, right? So you can rewrite this as n equals 1 over to infinity 1 over 7 to the nth power plus n equals 1 to infinity, sorry, I forgot to put the brackets before. So n equals 1 to infinity 3 over 7 to the nth power. If you remember it, since our value of ratio is less than 1, you can use infinite geometric series and it's going to converge. It's all because r is 1 over 7 and r is 3 over 7, which is less than 1 and less than 1. Okay, so let's remember our infinite series equation. S infinity is a over 1 minus 1 and 1 minus r. A is our first term. R is our ratio. So in our case, in here, this one, we're going to name this one as x1 and this one as s2. So our s1 becomes a over 1 minus r, which a is 1 over 7, and r is also 1 over 7. So it becomes 1 over 7 over 1 minus 1 over 7. So 1 over 7 over 6 over 7. So this is just going to be 1 over 6, right? And then let's calculate x2. x2 is a over 1 over r, which a and r is both equal to 3 over 7. So this becomes 3 over 7 over 1 minus 3 over 7. So this becomes 3 over 7 over 4 over 7. So this becomes 3 over 4. So S1 plus S2 value would be 1 over 6 plus 3 over 4. So this just becomes 24 plus 18 over 24, which is 22 over 24. This becomes 11 over 12. So the answer for this question is C.